So as I mentioned, it turns out the cloud providers sometimes actually want money because all these folks from Amazon require salaries. It's really weird. But hopefully we'll learn a little bit how to give them a little bit less money with Ryan. So here's Ryan. Thanks.
Is that better? Excellent. Let's rewind and start that over a bit. Hello, I'm Ryan Lopopolo. I work at Stripe, and I'm an efficiency engineer there, which means I spend a lot of my time focusing on how we can optimize our usage of cloud infrastructure and give AWS less of our money. A little bit about Stripe. Our mission is to increase the GDP of the internet. What does that mean? Well, it means we build economic infrastructure to help businesses large and small accept payments around the world. So let's talk a little bit about how we do that by spending less on AWS. Our goal here today is to optimize costs, and we're going to get into a little bit of some detail around the technical and cultural challenges we face while trying to achieve that goal. Like Ashina from earlier today, I also did my market research when it comes to making a deck, and it showed me that I need lots and lots of emoji. So we have about 109 of them in this talk and 50 slides, so we're going to go through at a pretty quick pace. I hope you're ready. So sort of the central thesis of the cost optimization work we undertake as efficiency engineers at Stripe is that in the cloud, cost and performance are aligned. In the cloud, every resource we buy is sort of metered. We pay for exactly what we need, which means we get to simultaneously make the decision about how well our application performs and the cost. And we can sort of like use this sort of intuition to use some of the same tools we use in our observability stack to optimize our costs as well. So go over a little bit the high-level goals that I hope you take away from this talk. We're going to first describe some techniques we use to measure AWS costs at scale, and we'll get into a little bit what scale means for us. Next, we're going to talk a lot about how to purchase reserved instances effectively to get the maximum savings that we can out of the cloud, specifically AWS. Reserved instances are probably the most impactful thing you can do to optimize your bill, so we're going to spend a lot of time on that. And then finally, we're going to talk about how we can sort of build like organizational level competency in cost optimization and sort of the specific technical and cultural challenges you might face when trying to do that in your company. Christine earlier today said that observability is a mindset. That mindset is used for thinking about systems and their state. And we're sort of going to apply observability concepts to our infrastructure costs today to see if we can evolve that system in a way that's productive for our business. There is a chart on this goal slide, and that's important because really all we're doing here is providing observability for our cloud spend. In fact, at Stripe, the efficiency engineering team and the observability team are in the same org because our goals are aligned and we use a lot of the same tools together. Because cost and performance are aligned, a lot of the tools are applicable to both domains. Just like we measure the P99 latency of our API with charts and metrics, we can do the same for our costs to gain insight into the behavior of our infrastructure and how we can operate it more effectively. There's a lot of colors on this chart that represent the different AWS products that we use. I'm betting you can guess which one is EC2. Cool, so I said that we measure AWS costs at scale. What does scale mean for Stripe? Well, we have hundreds of host types. These are sort of unique workloads that run on EC2 that are distinct puppet configurations that run individual workloads. We have a bunch of servers. And we have, in our history, over 1 billion AWS line items that we have received from them. What is a line item? Well, when AWS charges us for the products that we use from them, they send us 1 line item per hour per SKU. Just like in an on-prem world, you have a particular SKU for your R640 database server, AWS has SKUs for their products as well This could be 1 gigabyte month of S3 storage usage, or the number of X-ray traces that you've stored as part of your other observability stack. Sweet. So we are going to focus now on providing observability for our costs. What are the tools we have at our disposal in order to do that? Well, the big one is the cost and usage report. This is a log that we get from AWS that updates on a daily basis that has hourly line items for every SKU that we've consumed in our infrastructure. This report has a lot of information in it, so I'm going to try and distill it to its core here and talk about the things we care about the most. What is the line item? Well, there's a bunch of fields in it. These are the 3 we use the most. We have a usage type. This is the SKU I've been talking about. Here, we are looking at the SKU for an i3 4x large instance that happens to be in the US West 2 region. Below that, we have the usage amount. The units for these vary depending on the SKU. For instances, it's measured in instance hours. So with 0.52 hours here, it looks like we just spun this instance up over the course of the last hour. And then below that, we have this notion of cost. And here, we get that by multiplying the hourly cost of the instance by the usage amount that we have, to have about 65 cents worth of cost for this i3 4x large. We take these columns and put them together when constructing our cost attribution pipeline in order to define the edges of our flow network that allow us to pump costs through the system and figure out who owns what cost. The cost and usage report is fairly massive. It has about 200 columns in it. Don't recommend parsing this yourself. We load it directly into Redshift and let Redshift do the hard work for us. We have an ETL that we run daily that loads the report into 1 table per month. And then we generate this nasty view that allows us to query across all time to see our costs as they change throughout history. Let's go ahead and map those concepts of the line item into the actual columns that exist in the cost and usage report here. So here we have the usage type and the usage amount. These are pretty straightforward. They're basically one-to-one mapping with the SKUs and units that I showed before. But below here for the cost, we have this weird thing called the pricing public on-demand cost. What is this? Why is this weird notion of cost here? Well, AWS has at least 3 different measures of cost. They're all very confusing. They all exist in the cost and usage report. We're going to totally disregard 2 of them. We disregard the unblended cost and the blended cost because these costs are a lie. They vary depending on the vagaries of your billing setup and how much of your fleet is reserved versus how much is not. They don't take into account various discounts that you might get from AWS, so they're hard to reason about in a principled way, especially when you're trying to socialize the notion of cost to all these teams that you have in your infrastructure org that don't necessarily know the vagaries of the AWS billing scheme. Instead, we rely on this thing called the public on-demand cost, and as its name implies, it is the list price for all the AWS services that you can go find on their pricing pages on their website. The reason we like this is because these costs are one-to-one with usage. So when Team A spins up an i3 4x large over there, and Team B spins up a C5 9x large over there, these costs are directly comparable. A dollar of C5 is the same as a dollar of i3, regardless of whatever else we have going on in our infrastructure. Reserved instances make attribution of costs across instance family lines complicated since they're allocated on an instance family basis. So speaking in on-demand costs allows us to net out those differences. Additionally, you'll want to invest a lot of energy in tagging your resources. Tag hygiene is pretty important when it comes to cost management because AWS has this neat feature where they will pass through some user-defined tags that you've supplied to the cost and usage report. This is super useful because it allows us to bucket our spend on our own terms. And let's take a look at some tags that we use and that I hope you consider using as well. Here we have a notion of cost center, host type. This is the workload that we talked about earlier. Some owner, hopefully a team, and a VPC. Allowing these tags to bubble up through the cost and usage report is useful because it allows us to take them one step further and do attribution. We can say that these instances and these EBS volumes that are tagged to this particular workload in support of a product allow us to flow that cost all the way out to its eventual product owner, which is pretty powerful. Our ultimate goal as an efficiency engineering organization is to help the business understand what it costs to deliver the goods and services that we provide. Now that we've sort of like parsed this cost and usage report, we have this model of our spend and the resources that we're consuming. We can answer more interesting questions like how many and what type of servers are we using and how are they allocated across teams. This chart here is of our per instance family server usage, EC2 instance usage. Pretty interesting here is that the dimension we're looking at is instance family instead of instance type. And the reason we can do that is because we're undertaking this tricky normalization scheme and minimizing the dimensionality of our data. Common problem in observability is like a metric cardinality explosion, and we have the same thing here with AWS as well. If we were to take into account every instance size in addition to every instance family, we would have like an n-squared problem in terms of attribution. We'd like to avoid that. The way we do that is through a normalization scheme, which we've called X-large equivalence. Very fancy name, I know. Instance type, again, has this high dimensionality to it, and we can take advantage of the fact that within each instance family, the costs linearly scale with the size. So a i3 2x large is twice as expensive as an i3 x large. We can only do this because we're using the public on-demand pricing, which is like another way that these decisions kind of build on each other in order to simplify our cost reporting. We normalize to x large because every instance family we use happens to have an x large size. In the cost and usage report, AWS also exposes its own normalization factor, which I think uses small as the normalization size. Either way, this allows you to freely convert between costs and usage of all your different instances. This also makes the reporting a little simpler because it allows us to compare across teams with similar workloads that don't necessarily use the same instance type. So that was sort of the whirlwind tour of the cost and usage report and how we might use it to gain observability into our costs. Now let's sort of put the pedal to the metal, put it in practice, and use it to save some money. And the way we're going to do that is by buying reserved instances. To start and level set, like what is a reserved instance? Well, it's a contract that you enter with AWS that gives you a discount on a particular set of EC2 instances or RDS databases or Dynamo tables or what have you in exchange for a commitment to use those servers for a particular length of time. We think reserved instances are pretty important and that they account for at least 50% of all the savings you are able to milk out of AWS, which I highly encourage you to do. Because of that, it's like worth a lot of effort to understand them and learn how that your business can effectively use them. In terms of specific discounts that you might achieve, they can be as high as 52% on an individual server, which is a pretty big deal. This number comes from a C5 X large instance with a 3-year, no upfront convertible reservation. Let's break that down a little bit, what those mean. You have to choose a term for the contract that you enter with AWS. Your choices are either 1 or 3 years, longer term, bigger discount. The no upfront is the pricing plan. There are 3 of these you can choose from. No upfront means you don't pay any money upfront to AWS for the privilege of the contract. You pay an effective hourly rate each month as you go. That represents the contract price. There's upfront, which is kind of straightforward. You pay the entire amount of the contract upfront. And then there's a partial upfront, which is a blend between these two. The convertible bit means that we can take these reserved instances, and at any point later on in the duration of the contract, we can exchange them for another instance type. This is pretty useful because it gives us some optionality and makes sure we're not locked into C5s when they release the C6s, at reInvent next year or whatever. So that's like a lot of information about like what a reserved instance is. Now we want to buy the things, and buying them is non-trivial. There's sort of this like weird intersection between cloud strategy and bin packing and capacity planning that we need to sort through in order to make the decision of which and how many to buy. This problem is, again, highly dimensional, and we want to lock in as many decisions as we can up front to minimize the thought that goes into making these so we can make them regularly. This is the set of all the dimensions of a reserved instance purchase. There are 13 of them by my count, which is quite a lot of decisions to make in order to save some money. All the orange ones are decisions that AWS makes you make when you either make the API call or go to the console and click, click, click to buy some reserved instances. And the blurple ones at the bottom are decisions that we as a company need to make in order to feel comfortable about the decision to purchase reserved instances. We want to limit this search space, so let's go and make 3 or 4 decisions that can cut down the scope significantly. Before we get started, there are some of these we already know. Hopefully you know which region your servers are in and stuff like that, so we can sort of just knock out some of the easy wins right now. You know what region your servers are in. You know whether you're using dedicated or shared instances, hopefully. And if not, you can look at the cost and usage report to find out. And you should also know that you're using Linux or Windows or whatever in the cloud. So that makes 3 out of the 13 locked in as soon as we start. What do we do next? The next big decision we can make is to use regional scope for the reserved instances that we're going to buy. When AWS first released reserved instances, they were tied to a specific availability zone, which meant that they guaranteed capacity within that availability zone at the expense of being locked in to a particular zone. Expanding the scope of a reserved instance to a regional scope causes us to lose the capacity assurance guarantees, but in exchange for that, we get this thing called instance size flexibility, and we allow our reserved instances to float among any AZ in the region. The reason we're willing to make this trade-off is because capacity assurance doesn't really work for us. It really only works at the edges. In order to effectively reserve capacity, you need to have more reserved instances than the servers that you're already running. Otherwise, you're just reserving capacity that you've already spun up. We have a goal to never have unutilized reserved instances, so that strategy is kind of out of the question for us. Additionally, the ability to have reserved instances float among all AZs in a region gives us higher utilization, which means we're wasting less money and allocating RIs efficiently. Instance size flexibility is perhaps the most interesting bit of this, and it allows us to apply that linear scaling that we talked about earlier to the reserved instances themselves. Basically, we can decide to buy 9 C5 X large reserved instances and apply those to 1 C5 9X large instance. So again, cuts down the dimensionality of the search space and makes it much easier to allocate reserved instances across our fleet. Awesome, so we've locked in 3 more dimensions. We locked in the scope. We don't care about capacity assurance, and we know what instance size we're going to buy our reserved instances for. We're always going to buy X large. What next? Our next step is to engage the finance team. Reserved instances are an important decision for any business since there's a contract associated with it. There's capital outlays. So it's as much a finance decision as it is an engineering decision. Engaging them early in the process is probably good to make sure that we arrive at a solution the company is happy with. The decisions we need to make for the contract term, whether or not we want flexibility in being able to convert to a different instance type later, and the full versus partial versus no upfront purchase pricing is all sort of best answered by the finance team. So we're going to delegate these decisions to them and lock them in according to our cloud strategy. So now we've locked in 3 more dimensions. We've got the contract term, the offering class of the reserved instance. We always use convertible. And the pricing plan. We always use no upfront. We're almost there. We're getting there. The next thing we want to figure out is how many, when do we buy these things? We need to put the pen to paper and make the purchase. How do we do that? Our first step is to automate this with a batch job. We have an ETL that analyzes the cost and usage report on a daily basis. It takes a snapshot of our fleet and compares our actual reserved instance utilization to our coverage targets and figures out what the deltas are. What's a coverage target? A coverage target basically means, for the C5 instance family as a whole, I want 90% of all of the instances to be tagged with an RI. This is sort of a useful metric because it allows the efficiency engineering team to measure their own effectiveness. We can see how much spend we were leaving on the floor by lagging behind our purchasing duties. Additionally, having coverage targets makes costs more predictable for finance, which they greatly value. Next, we've got this ETL. It's figuring out how many reserved instances we need to buy, and it's comparing them to our target coverage. We need to actually know we need to make the purchase, and the way we do that is by firing an alert. We fire an alert as part of the ETL, and that triggers a manual purchase, which we will kick off the next business day. The reason we trigger a manual purchase is because there's lots of money flying around here, and we like to have approval steps from finance to make sure we are doing the right thing. Checks and balances on the automation. There's this tension between making sure we are not constantly alerting. And the way we do that is by having a coverage band that we apply around our target coverage of 10%. So any fluctuations within this 10% band, we let go, and only when we fluctuate outside that do we trigger either a purchase or a conversion. Awesome. We've locked in a few more dimensions. We know the instance family. We know the instance count. Now let's talk about this last thing, which is ownership. Reserved instances are allocated globally across all of your AWS accounts that are attached to your consolidated billing organization, which means that it's beneficial to have one central authority that owns purchasing them for the entire organization. We manage reserved instances centrally. My team, the efficiency engineering team, is responsible for making sure we do this correctly for the entire fleet and for all of Stripe. We did it. Locked in all 13 dimensions. Sweet. We've purchased some reserved instances, saved about 50% on all of our cloud spend. We're ready to rock and roll. Let's see what else we can do to build these processes into our culture to make sure that we continue to optimize costs going forward. So there's this notion of being competent in optimizing and managing our costs. And this is important because it's not only a technical problem, there's also a cultural component to it. We need to embed processes in our organization to make sure that we are thinking of this as we design features and go to market with products. To start, let's take a look at some examples of how we've solved the cost optimization problem with engineering effort. This whole cost optimization thing is another global optimization problem, just like the reserved instance purchasing that we just talked about. Again, we made efficiency engineering the owner of optimizing our entire cloud stack, whether that's code, resource selection, or allocation. We treat the cloud as a single unit and do the link time optimization just like GCC does. Ultimately, the program optimizations we're going to look at in the following slides boil down to which, when, and where. All right, so starting with which. Instance right sizing is a pretty productive activity. It's likely that instance selection is pretty ad hoc across engineering, and putting some effort into being thoughtful about the decisions here can save you some money and make you more efficient as well. And the way we can do that is with a global inventory of our SKUs that we can derive from the cost and usage report. And if we bucket them by workload, we can see when similar teams are making different decisions in terms of their infrastructure, and trend those teams to use the right tools for those workloads. A good example of this is our data warehouse and batch clusters. We didn't need all the disk capacity that i3 instances provided because our Hadoop workloads are S3 backed. So we migrated from i3s to R5Ds, which gave us a cheaper cost per core and more efficient cores at the same time, which is a win-win for everyone involved. The next project we undertook was to adjust the auto-scaling policies that we were applying to our CI workers. This is the when question. The cheapest server, I'm sure you all know, is one that is turned off. So we went about and turned off all the servers when they were not effectively serving our engineers. We have several global engineering offices around the world, and we use a follow-the-sun pattern to scale up and scale down instances in regions local to our engineering offices according to peak build times in those offices. Especially the afternoon rush as people are aiming to get commits landed before they leave for the day. Another project we undertook was the notion of minimizing cross-availability zone network traffic. This is the where aspect of the questions we're trying to answer. This again comes back to our Hadoop clusters. We do not use AZ-aware HDFS. And this means having a cluster that spans multiple availability zones does not buy you any additional redundancy. You might have multiple copies of the block in the same AZ. It does buy you, however, a ton of crosstalk between all your AZs, which is very expensive. We managed to consolidate our clusters to a single AZ, and we're able to cut our costs in half by making sure we did not have the chatter. So that was some of the technical bits of projects we undertook in order to optimize our costs. But it's more than that. There's some cultural change that needs to happen here, some organizational change. And that's because the system we're talking about here is more than just code and infrastructure. There's people involved. And in order to be effective, we need to change the culture of our organization so that cost management, cost optimization is sort of a first-class concern while we're thinking about designing infrastructure and solutions to problems. One way we do that is with scorecards. A scorecard contains information about a team or a product's costs. And the hope is that these scorecards allow teams to independently optimize their resource usage. There's two primary types of scorecards that we use. The first is a monthly snapshot of each team and each product's consumption of shared infrastructure resources. We have two different types of services in our infrastructure. There's sort of like application services that are tied directly to one product in support of it. And there's things like platform services. These are things like the batch clusters, the Kubernetes clusters, the database. And these are incredibly multi-tenant and shared across a bunch of products. So being able to use SLI metrics from our observability stack to slice and dice these costs across all the teams that consume them is useful for computing the true cost of each product. Additionally, we have sort of a more online velocity-triggered notification system that we have that will alert teams via email to both tech leads and management when their spend changes in ways that we did not predict. One kind of cool bit about here is we treat all of this scorecarding as part of a graph, a flow network. And one thing that efficiency engineering can do is manipulate the edges of this flow network in order to make things artificially more expensive or cheaper to encourage the behavior that we want to see in the organization. For example, if the orchestration team releases an updated Kubernetes cluster that we want folks to migrate to, we can make it artificially cheaper to run your pods there in the hope that the org would self-select into running their workloads there. Another cool tool we can use in order to change the culture is this notion of attributing costs all the way out to products. Ultimately, it's the products that we sell that make the company money, and being able to compute the margin associated with these, particularly the infrastructure margin, is useful in the design and development of features. I think this is the most fun part because it has knock-on effects elsewhere in your organization. If you know the infrastructure margin associated with a particular product, this allows sales to price deals more competitively, and it allows your marketing team to have more effective go-to-market strategies to optimize conversion on the areas of your product that are more margin positive. And finally, we have some rah-rah positive wins here. We like to embed the culture of doing positive optimizations. So we want to track these wins in a durable way. We have a global metrics dashboard that anyone in the company can see, and we log every cost win, no matter how small here, so that folks can see all the good work that all the engineers are doing. That's it. We've sort of optimized our costs all the way here. To recap, we've used the cost and usage report to add observability to our costs and categorize and attribute them. We learned how to buy lots of reserved instances and lock in that 50% discount that Amazon is just giving away for free. And we learned how to undertake both technical and cultural initiatives in order to make good on the promise of optimizing our costs. Thank you very much.
%. I missed the 50% off thing because I had to go set up the bar for tonight. Now I got to watch the recording. Thank you very much. Is there any questions at all? Go ahead and you mind just yelling it out? The mics are in the back there. Or I'll just bring you this one.
Is there a way to attribute cost to network traffic?
I have imagined using the flow logs in order to do this. Basically, like go from flow log to instance ID to historical record of instance ID and cost and usage report to like cost allocation tags, and hopefully you can tie a story together. This probably requires a super gnarly ETL that I have not had the stomach to create yet. Yeah.
Thank you. Thank you. Thank you. One question about the convertible instances. When you get a convertible instance, do you know the percentage of instances that you actually end up converting into new reservations?
We were able to go probably like a year before having to convert anything. Most of our conversions have been driven by our recent right-sizing efforts, as well as like new instance families that AWS has introduced.
Okay.
So we expect to have a fairly regular cadence of these things as like reInvent announcements come out and stuff like that.
Got it. Thanks.
Great. If we get one more hand, that's all the time we have. Thank you very much for coming.
Thank you.